filter. It goes inside the setup, and the whole point is water comes in, the dirt sticks to the surface. Our plan is to make it not stick so that water flows more, less waste of electricity. So what we have designed, like a main function of this is to save water, and we're actually doing that. The amount we clean by this is 2 minutes. It's the same amount that we clean by hand in 10 minutes. Those were the main objectives. Shelby can take a bit towards that.
Our roller axle mechanism. It's with bristles on it, so we can shove it in the filter, and it will accommodate different diameter filters by deflecting the bristles and just holding it in place. And this is on a low friction bearing on this axle, so it can spin pretty freely, because when we get this filter pretty wet, it's kind of hard to turn, it gets heavy. So this goes inside the filter, and this is placed on in these sliders right here, and it's able to be adjusted on the side to go up and down for different diameter filters for the pipe.
Yeah, see this? The pool never gets this dirty. That's the whole point we're trying to show. Like, let's say you don't clean your pool for 200 years. That's how it's
the different diameters. This is placed on top, and we have like a pin that goes into the slot, so just to hold it in place and not falling off. We have two pipes that have holes drilled in the middle, on the bottom of them. 16-inch holes, smallest, that will allow us to get the certain amount of pressure to be able to spin it. This, what we call, is our main pipe. This is placed right over the filter, so we can get maximum cleanage right there. So instead of hitting it at an angle, which it won't go, the water won't go in the middle of get like the dirt in there. So we have it like directly over. This actually hits it on the side to go make it spin. So that's what our purpose is. And the holes are staggered. So we have a hole right here, and the pipe. This pipe has a hole in between the two. And to use it, these are splash shields because it's really easy.
The first thing we did last semester when we were first attempting to do our calculations was we went over to Shelby's house and figured out how many gallons per minute flow rate she had based on her hose, and we went, as Praveen mentioned earlier, it took us about 10 minutes to clean each filter really well. I have an example of a filter we recently did at Shelby's house that I actually cleaned. This took me about 6 minutes to do, and as you can see, it's not really perfect. On my hand, it took me 6 minutes, and my back was sore for about a half hour after that. So that was fun. This is the filter that we cleaned using the machine. This we only put in for half the time, a total of 3 minutes. You're not going to be able to clean the very, very bottom of the creases because the dirt gets trapped in there and packed in. The only way to really do that is if you're doing it by hand, you have to go spread the filters and do them individually, which probably take upwards of an hour to get each filter complete.
Oh, one thing I like to mention before we actually turn the thing on is how many different iterations we had to go through with this design. Like, especially the nozzle pipe. That was our main trouble, getting it to turn and clean. So we first tried a single pipe, about 1 inch PVC, going right underneath it. Well, actually at an angle first, because we wanted to just use one to spin it and clean it. But when you hit it at an angle, it doesn't go into the fold very well. It just hits it and spins it really, really fast, and doesn't really get any cleaning done. And another design that we tried was putting a paddle wheel on the roller and having another separate nozzle with larger opening, more force to go through it to turn it, and that didn't work very well. So we did a overhead design because it's just easier to put this on it and just have it clean it from the top. Especially with these two pipe design here, you can spin and clean. So,
and even for this one right here, we had to go through 8 different models because MATLAB, it says, okay, this nozzle is gonna squirt out this much water. Never. But yeah, now we can turn it on and show you how it works.
All right. striking effect because the nozzles aren't spraying the whole filter. That's one of the things we also tried to design with our nozzle. We tried making it out of rapid prototyping it, having like a teaser setup. But that hole was better, this simple hole, because one, we were taking a lot of time trying to fine tune this nozzle design to work. And this works just as well because it actually gets more force in there to clean it. So when we move it a little bit this way, we're just kind of like making the nozzle cover like the whole filter a little bit better.
The holes for this pipe compared to this pipe, the opposite?
Yeah, the rotation pipe looks like it's most of the surface dirt. We're relying on this pipe to actually get down into the hole. And the main thing is we're working with a certain amount of pressure here. If we try to divert the flow even more, we're going to lose some pressure and not get it cleaning and spinning. So that was one of our main challenges as well. So got a little bit of streaking effect going
Want to
on.
come forward and see? That's pretty much what we have, is a little bit of dirt there, bottom of the filter pleat. Where it's reaching though, it's actually cleaning very well, so I don't know if you can see that. So compared to how it looks before and how it looks after, you're getting at least, I'd say, 90% of it clean.
Right, and we had to compromise on some of the cleaning for like spinning. And our compromise was we needed to use some of the pressure to clean it and to spin it. So we had to to get it a certain amount of cleaning done, we had to lose some pressure. Or spinning done, we had to lose some pressure on that.
Like if we put in more nozzles in the main pipe, what happened was the pressure was too low. We didn't have enough pressure for the side one to turn. So that was a compromise.
One advantage we have over their design is ours can fit any length of control filter. Theirs, depending on what size pool you had to buy one. And with the larger Master Blaster designs, it only cleaned half of it at once. You had to take it off, flip the filter, and then clean the other half. This, you get the whole thing done at once.
Let's talk about water savings. We just measured it roughly at my house. Hello, how are you doing? We measured it roughly at my house. And my house is like 7 gallons per minute, roughly. 70, and it takes about 10 minutes to clean it back in. So that's 70 gallons. So this, we measured it yesterday, it was about 10 gallons per minute. And this took about 2 minutes? 2 minutes,
20 seconds.
2 minutes, 20 seconds? Okay, so that's about 20 gallons of water. So another compromise we made was for the cleaning, less cleaning, more water savings to balance.
Even though you might not necessarily clean it 100%, if you save, 70-80% of the water and 70-80% of the time, overall throughout the year you're still saving water and you're saving time that you would spend cleaning it. Even though you might have to pull them out and clean them one more time, you're taking a lot less time to clean the filters each time.
One of the main reasons the other products failed was the price. $180 for Master Blaster at 3000 series. It goes up to $25. Look at something.
Where instead of horizontal,
We went instead of vertical orientation. We actually were thinking about that in the beginning, but we decided to do horizontal because we were getting a built-up of like crud on the bottom when you just have your filter like that and you're spraying. It's like all the dirt's going down on one end, so you're gonna have to like flip it over. So we decided to clean it like this because it's all even.
If you try to clean it horizontally, what happens was, as Shelby mentioned, all the dirt goes down to one end, then you have to flip it over, and that then spray it down again, which washes the dirt back down to the other end, so you're really just moving it back and forth.
Yeah, not going anywhere.